On a remote mountaintop in the dry Atacama Desert in northern Chile, an incredible scientific adventure is about to start. This is where the world's largest and technologically most advanced astronomical telescope will soon open its eye towards the night sky and let us glimpse at the remotest borders of the universe. This immense project is part of mankind's ongoing quest for knowledge. We have always wondered about the world we live in, asked questions about our origin, our surroundings, and ourselves. Some of these fundamental questions are astronomical. Searching for the answers requires the use of instruments and methods at the very forefront of contemporary technology and methodology. How old is the universe? How did it begin? Will it ever end? Is there life in other places? What is matter? What is time? Why is the universe the way it is? These are just a few of the many questions for which answers are hidden in the depths of space. Some people, scientists, devote their lives to the search for these answers. We cannot travel to the stars, but a careful analysis of the light they emit allows us to unveil their secrets. Every night, telescopes on remote mountaintops point toward the sky to collect the precious light particles from outer space. At La Silla, the observing site in the Chilean Atacama Desert operated by the ESO, the European Astronomy Organization, 15 telescopes continuously scrutinize the sky. Through meticulous observations, astrophysicists all over the world are trying to put the great puzzle together and begin to understand the grand pattern of nature. But larger telescopes are needed. With new technology available, the time has now come to build larger and more efficient telescopes. 8 European countries have responded to this challenge, and this is why ESO's astronomers and engineers are now working on this unique telescope project. The 16-meter Very Large Telescope, or VLT. The VLT is not just one telescope, but an array of 4 telescopes with giant 8-meter mirrors, supplemented by 3 smaller instruments. Each of these 8-meter telescopes will be able to obtain images of extremely faint celestial objects. In fact, they could see the faint light from a glowworm more than 30,000 kilometers away. Each telescope will be among the largest and most efficient in the world. And when their light is combined, they will become the most powerful telescope ever built by man. The VLT will have a light-collecting surface equal to a 16-meter telescope. The most powerful mode of operation comes about when the light from all of the telescopes is combined coherently, in phase. This way, the VLT becomes a giant interferometer, which permits us to obtain sharp images of objects that subtend a very small angle, only 500 nano-arcseconds on the sky. This corresponds to seeing individual astronauts on the surface of the moon 400,000 kilometers away. The VLT's fantastic capabilities make dreams come true for scientists. It opens the door to entirely new research possibilities. This achievement, however, is only possible when the disturbing effects of the turbulence in the terrestrial atmosphere are neutralized. We see this effect every night as the twinkling of the stars. Fortunately, optical engineers from ESO and national research centers have pioneered the development of a revolutionary device which can compensate for these atmospheric effects. The application of this new technology, known as adaptive optics, now makes it possible for scientists to exploit the full potential of the VLT. The realization of the VLT project represents a formidable challenge to industry. This giant telescope uses a host of new technology. Indeed, it can only be built with the innovative application of the most advanced technologies available. For instance, the VLT mirrors are the largest monolithic mirrors ever produced in the world. Completely new techniques had to be developed to cast these enormous pieces of glass in Mainz, Germany. The demand for ultimate optical perfection also places very special requirements on the polishing procedure. In this most delicate process, the opticians must polish the mirrors to a precision of a few hundred thousandths of a millimeter. All in all, it takes almost 4 years to manufacture one of these mirrors. Meanwhile, a number of companies are busy with the huge telescope structures, buildings, and auxiliary instrumentation. More than 5,000 people worldwide are involved in the VLT project. While the mechanical, optical, and electronic parts for the VLT telescopes are being prepared, the telescope structures are assembled and tested at a factory in Italy. This pre-assembly enables ESO's engineers and technicians to verify the functionality and compliance with technical specifications before the parts are shipped to their final destination, Cerro Paranal, a 2,640-meter high mountain peak in the Atacama Desert in northern Chile. Here, in one of the most desolate places on the surface of this planet, nature has created a remarkably dry climate. While on Paranal the conditions for life are very hard, it is one of the best locations for an astronomical observatory on Earth, providing up to 350 cloudless nights a year. The VLT is a giant leap forward in astronomical technology. With its unequaled ability to capture the faintest light from the most remote objects, it can observe more distant objects and therefore look further back in time than any other existing telescope. It can study objects as they looked when the universe was very young. This way we will learn more about the true age of the universe. With the VLT, we will also be able to measure the real density of the universe better than with any other telescope. Maybe it will then be possible to decide whether the universe is open and will expand forever, or whether it is closed and the current expansion will come to a halt at some point in time. The VLT will produce sharper images than any other optical telescope, and we can use it to search for planets around other stars. Life can probably only exist on Earth-like planets, so the discovery of such planets would be a very important step forward to learn whether life exists elsewhere in the universe. The VLT will take us into unknown territories, far beyond today's horizons in time and space. Which of nature's many closely guarded secrets will it unravel? Which new and exciting insights into our own origins will be gained with the VLT? We do not know yet, but when it is ready on its remote mountaintop, the VLT will help scientists in their search for answers to some of mankind's most profound questions.